and you flip the things across, that means this is going to be here. I'll do it in green. This is going to be here, and that's going to be there. Okay? You see how these flipped? And this is going to be there, and that's going to be there. Okay? Or you could pick a point in here, an intermediate point like negative pi over 4, and graph it and see what happens. Okay? So I'm not going to do the intermediate points. Are you feeling pretty good about this? Yeah. Okay, this is for you, so we'll do it your way. So this guy right here, as the green guy, okay, well, okay. This is a little confusing. I think it might be best if we, did you talk about limits in calculus, pre-calc?
I don't believe so.
That's the thing I keep hearing, which is scary because that's like the thing you do, right? Algebra, you learn, algebra 1, you learn how to factor and FOIL. That's the thing you get out of that class. Like there's other things, but that's the thing you gotta know. Yeah. Out of algebra 2, you guys learn about a little more on parabolas, but really the big thing is like foci, like ellipses and things, right? Circles, how to graph that, x squared plus y squared, right? The big thing out of pre-calc, which was first semester for you guys, is really limits. That's kind of scary. I will make sure Ms. Walzak is aware of that. Okay. So anyway, the idea here, without saying limits, is that, see this black line, right, our original graph right here? As it gets closer to our asymptote, our domain restriction, pi over 2, it also is going up in the positive direction. So as it gets closer to this guy, the red line, it's going positively. Let's graph our restrictions over here first. I think that'll be easier without talking about limits. So our range here is negative pi over 2 and pi over 2. Range is y values, right? So let's plot those, pi over 2, negative pi over 2. Do we see what I'm doing here? Yeah. Ranges is a restriction on how high you can go, right? There's ceilings, ceilings and floors. So as we go towards pi over 2, we're going positively. So as we go towards pi over 2 over here, we're going positively. Which way is positive, this way or this way?
Right.
So we're going to go like that. This is a really awful y equals x line. Okay, so yeah, ignore this. And as we get closer to negative pi over 2 for our black line, we're going negatively. So as we get closer to this line, we're going negatively. Do you see how I did that? That's your graph. Last one. And then we'll call it a day. You can go home and not have to think about math for at least another day or so. Which you should. In fact, I think you're good enough right now where you don't have to think about it at all. You're putting in the time. Please don't think about math for a day.
I'll try.
Okay? Don't stress about it either. Easy for me to say.
Right.
Right? Don't do that. Right? Whatever you're doing, just don't. Right? Like why don't you just stop?
Yeah.
You're like, oh yeah, you know what? I should.
I didn't think about it.
Right?
Yeah.
You know, like. Yeah. Oh, okay. Sure. You're right. Good idea. All right. So you're asked to graph this. F of x equals. Do I want to use secant or cosecant? Let's use cosecant. Yeah, let's do that. Okay, so f of x equals cosecant, inverse cosecant of x. So let's graph the general case, right? And that's going to be like this. What's the reciprocal of cosecant?
Sine.
Sine. So let's graph sine as kind of a placeholder for us. Did I teach you this method?
Yep.
Okay, good. This is nice. And then 1 and negative 1, because the basic has an amplitude of 1 in both directions. Okay. So let's do sine in blue. Sine is going to start low and go here. Same thing over here. Cool, so that's sine. Since it's the reciprocal, the real graph, this guy right here, the real graph is going to be the reciprocal of the initial graph. So we're going to take these guys and flip them. That's all. And when you flip zeros, right, which is what these guys are right here, you get undefined. Do we understand that?
Yeah.
Cool. So the red is really what our graph is here. The blue is just for fun to help us make it pretty simply. We can erase that or not. I'm going to, because the real graph isn't the blue part. It's just the red part. And that sort of works. Okay, cool. Another nice feature of the smartboard is the undo button. Okay, so this guy right here. All right, so now we've got our graph, and we need this to pass the horizontal line test so we can graph an inverse. Right now, it does not. So we need to restrict our domain. Our domain restriction, which I probably should have done in a different color, needs to be as close to the origin as possible while also accomplishing our goal of letting it pass the horizontal line test. So here is a pretty good spot. And again, one way to know this real quick is that this is the inverse of, or the reciprocal of sine. And so if sine has a restriction there, probably a good chance that cosecant does too. So let's draw our thing here at negative pi over 2 and pi over 2. That asymptote will get you. All right, so, and this works now because this guy, if we draw a straight line across, it will erase our guy. It will pass the horizontal line test, and so will this guy. We split it in half, that's okay. We do that to sine all the time when we put a domain restriction on there. Right, our domain restriction is here. It still splits it in half, it just doesn't look as funky, right? So that's okay, that's the goal. So now we've got this. How do we do that when we want to plot that over here? Well, our x's and our y's switch. We said our domain restriction was negative pi over 2 to pi over 2. So our range restriction is now what? The same dumb thing. Cool. So let's do that real quick. Negative pi over 2 is here. Pi over 2 is here. Because they're y values, because they're range. We also have what inside here other than points? What else is inside there?
The origin.
Yes, but what else? What else do we have inside here that's part of our graph? We got some points.
Points.
We've got
Oh, we have one of the
an asymptote.
Yeah.
This is the thing everyone forgets on this one. So let's move our asymptote. And again, it normally goes up and down, so now it's going to go left and right because we switched our x's and our y's. So instead of an asymptote going up from 0, we're going to have it going left and right from 0 from our origin. So here it is. I'm doing it in red to signify asymptote, okay? So now we have that. Now let's plot our points. What's the coordinate of this guy down here?
He is negative pi over 2, comma, negative 1.
Cool. So that means we're going to plot negative 1, negative pi over 2 over here. This guy is?
0, 0.
So we flip him. This guy is?
Pi over 2, 1 pi over 2.
So 1.
Yeah.
Well, you're telling me the thing,
Yeah.
right? So it's pi over 2, 1 here. And it's going to be 1 pi over 2 here. Okay, cool. So let's plot them. 0, 0 is easy. Interesting, right? Whoops, we don't have a point there. Why do I have a point there? Because I was graphing sine. That makes sense. There can't be a point on an asymptote, you idiot.
Oh.
Jeez, not you, me. What am I thinking?
You need to give your heart a break, like Demi Lovato says.
That's on there. All right. Wow. I can tag my videos with Demi Lovato now. Everyone will watch them. All right, so we need to plot 1 pi over 2, 1 pi over 2. You can have a point on a restriction because it's including, right?
Yeah.
That's okay. And then we've got one over here at negative, right? Negative, negative pi over 2, which is here. Cool, so we got our 2 dots. And nothing in the middle. That's nice. Is it possible for me to have a line connecting these two things?
No.
We've got something in the way.
Asymptote,
Asymptote. Can't. Okay, so let's ask ourselves. This point right here, which is negative 1, negative pi over 2, coincides with this point over here. Do we see that?
Yeah.
So this point is going negatively as it approaches our origin, right? As it approaches the origin, it's going negatively. So as it approaches the origin, this is the origin, right? As it approaches the origin, it's going negatively. Is the negative right or left? As it approaches the origin, right, it's going positively. So as it approaches the origin, this is the origin line, right? It goes positively, right or left?
Right.
Ta-da!
Doesn't seem too bad.
Yep.
I dig it.
Okay, that's it.
Alright.
And again, if you can draw this lickety-split, you can see, oh, got it, And technically, this is what a limit is. Okay, hang on your butt. Right, you said it was easy, so now I have to make sure it looks really hard. A limit is a line that gets as close as possible to an asymptote, right? So what's the furthest point we can get without actually touching this? And of course, that's infinite, right? You can get infinitely close, right? There's always more fractions in there. And so that's what these things are doing, which is why if you know what limits are, it's not so weird to think about how as we approach the limit of 0, right, the origin, we're going positively in that direction. It's less confusing, but I think you nailed it. So if you've got this, you could get 100 on this final.
Sweet.
And you know how my finals aren't easy, so you need to put that on the fridge after you get that, okay?
Sweet.
Cool. That's all I got for you, man.
I gotcha.
Do you have questions for me?
Can we just do a quick recap of everything, not go in depth with
Great.
this is this.
Okay, so what is going to be on the final and what that means. Okay. So, here's the final I took. Did I tell you guys that depending on how well I do on the final, I'll grade you on a curve,
I heard
right?
that,
I will
yeah.
set the curve. Yeah,
Yeah.
good luck.